I'm Mrs. Bollins. I'm part of the leadership team and also head up engineering, and I'm going to do this talk about the engineering GCSE. We do the one by AQA board, and I want to tell you lots about it. So I want to start off by explaining what engineering is, because it's such a vast subject. A lot of people don't realise all of the things it entails, but basically what engineering is it brings good ideas to reality, and it's about being a problem solver and being creative, and it can cover all types of engineering. So we've got on the board here aeronautical, CAD work, robotics, electronics, chemical engineering, civil engineering. It's such a massive topic. One thing that some people do get confused on is that this is like car mechanics, and mechanical engineering is a part of engineering, but this course won't cover very much apart from a little bit on engines. Okay, to give an overview of the content of the course and how it's laid out. So 60% of the course is an exam. It's a 2-hour paper. It starts off with multiple choice questions and then goes into sort of longer sort of 6-mark sort of questions at the end, and I'll show you some of those a bit later on. The other part of the course is making a portfolio. It's now called an NEA, so a non-examined assessment, and they get a brief from the exam board and they work towards it over about 60 lessons we spend on the coursework. The topics that we'll cover across both the portfolio and the exam are engineering materials, so that's all our metals, composites, polymers, and we do a tiny bit on timbers. We look at different manufacturing processes, so looking at things like lathes, milling machines, drills, different ways to saw, cut and bend metal. We look at things like casting, and then newer processes like laser cutting, 3D printing. We also study systems in a lot of detail, and that's where my specialism's in. That's what my engineering degree's in. So we look at things like programming. We've got microbits and we've got Arduinos at school. We look at different electronics as well, and doing systems diagrams like circuit diagrams, flow charts, block diagrams. We do also lots of testing and investigation, lots of finding out things by doing different practical activities and then testing their product at the end of their portfolio as well. We also look at different ways we can test materials. Then we have to study about the impact of modern technologies, that's for the M part of the exam. So what difference has having 3D printers, laser cutters and so on had on the environment, the factory, our lives in general. We're also going to learn lots of new practical engineering skills, so they're going to use sheet metal work they haven't done before. We're going to teach them how to make circuit boards, lots of electronics, and lots of reminders of things they've done in previous years in technology as well. 25% of the exam is on maths. So I quite enjoy the maths in engineering because it's working out things like costs. There's bits of trigonometry and Pythagoras, working out areas, looking at things like gear ratios as well. Why should they pick this course? This course I think is really exciting. We're going to learn lots of really cool new stuff. You've got a mixture of working in the classroom and in a workshop. I would say it's about sort of 50-50 split between working on computers and then working on drawing and on practical skills. You're going to apply your skills to work-related solutions. We link up as well with local engineering businesses and find out what sort of skills they want from students coming through as well. We use computers loads, as I was saying, about half the time we're on computers. So it could be you're typing up a plan, you're doing a spreadsheet of costs. Obviously we use it as well to do computer-aided design, to make circuits and test them, to do programming as well. I like to keep a really big range of different engineering sectors in what we're doing. So some of it's to do with what the exam board wants us to study, but some of it's also to do with what the interests of the pupils in front of me have. So they'll do quite a few surveys for me over the time of the course so I can find out what they're interested in and, you know, keep them really engaged on what's going on. there'll be lots of designing, making and investigating different engineering products as well, which I'll show you next. So how we run the course. So if you've been taking DT in year 9, you might have done some of these projects already. So pewter casting, USB lamp and systems were originally engineering projects that we've moved down. If you haven't taken it in year 9, the best ones to sort of relate to are in year 7 you made a jitterbug, and in year 8 you did the steady hand game. So those are the projects that most closely link to engineering. The plan for year 10 is to build up loads of skills and knowledge. So we do lots of mini projects, lots of nice exciting things to get used to all the different bits we're going to need for when we get onto the coursework and the exam. So we start off by making a little metal race car, which is in the top right hand corner of my slide. We're learning about engineering drawings, how they're laid out, how to understand them. I'm also trying to get them to be really independent. So if the answer's in a drawing, I would get them to go back and look it up. I think that's a really important skill to learn if you're going to move forward in engineering and in life in general. We're going to learn lots about different metals, processes, health and safety, and obviously the practical skills of using sheet metal. And they get to give it a nice spray paint at the end as well, which they enjoy, and add a few details. Then we do a load of problem solving challenges. This is lots of different little bits of theory that we need to cover for the exam board. So we look at different structures, we look at aerodynamics, so we're going to make paper planes and rockets and investigate them. We're going to make parachutes and look at different effects on of the size and so on, and how that affects the parachute working. We'll do some work on materials testing. We'll do a little practical activity to learn more about quality control and quality assurance. Then we go on to do an electronics project. I might change it for next year. What we've done in the past is a laser bug, so that's at the top near the metal race car on the slide. Looks very similar in layout to the jitterbug. Apart from this one, you need to shine a light on it to get it to start. But we might move to a different electronics project this year to have a change. But during it, they're going to learn about all the different plastics, the vacuum forming, the laser cutting and costing, as well as being able to draw a circuit on the computer and convert that to a circuit board. Then we move on to sort of drawing skills and computer aided design. We do a bit by hand and quite a lot on the computer. So we've got a couple of packages that we use within school, and they feed directly to our laser cutter and 3D printer as well, which is really useful. We then start to look at mechanisms, which they did do in year 8, hopefully, but looking in a bit more detail about levers, gears, cams, pulleys, that type of thing. And then we also bring in some knowledge of hydraulics and pneumatics. So they will make, I don't know if you can see on the slide just above my head, they make like a cherry picker that we use a syringe to move up and down to learn about that. That's quite a nice activity. Then we're going to sort of plough on to our microcontrollers, so learning the programming of a microbit, which uses blocks, and then using Arduino, which uses more like programming language. We also learn how to wire up on a breadboard, which you'll see on some of the coursework. So we can do some really cool different programs and learn lots about that too. And then we do a sort of design project to get them prepared ready for their NEA. And then in year 11, most of the time we're working on the portfolio. The brief gets set in the end of year 10 and it changes each year. The types of things we've had in the past, the original one they came up with was we had to design a machine to sort 3 objects of different sizes. The first year of the course was protecting an item, valuable item in a public space. So we were looking at different locks, safes, door wedges, that type of thing. Last year was a device to help someone with sport, and we really enjoyed that one. Different things we had were sort of light gates to check people's speed, balls with built-in sensors. We had like things to count how many laps you'd done in the swimming pool, that type of thing. And then this year's brief is to design any sort of device that uses alternative energy, which is really exciting as well. So we've got lots of solar panels, wind turbines, some people are using water or tidal power as well, and they're thinking up different devices. So we're trying to keep things quite as simple on the other side as possible. So the sort of things they're doing are torches, little toy cars, things to scare a bird away, that type of thing. What they have to do in the coursework, and there's some examples on this page and the next. So the first thing they do is they put down all the ideas of what they could possibly design. Then they start to sort of come up with different research and design ideas, and then they have to do a variety of different engineering drawings. So on this page there's two different systems drawings. So we've got a block diagram and a flow chart. I've just put them on so you can see the kind of detail that we need for our coursework. And then they go on to do more sort of develop design ideas, CAD drawings of their different designs. These are ones from last year when they were looking at different sporting devices. And then they get on to prototyping a model. And it doesn't have to be like a final real finished piece that you would buy in the shop. It's to show that their idea will work. So a lot of them cut things out, as you can see on the laser cutter. Lots of them use the Arduinos to do some programming to go with it. They get more marks if they put electronics in there as well. So lots of them add some sort of circuit in there too. So the one at the top I think was like light gates, and the one at the bottom was like a balance board. And when it tilted, it lit up in different places on the board. So they were very different designs. It's quite interesting as a teacher because everybody's doing something completely different, which is interesting to manage sometimes, but it's really good for the pupils because they do own the coursework and it gets them really independent, and it's interesting for them all to see different things going on and get different ideas from each other as well. And then this is just ideas of what the exam questions are like. We have a textbook that we use in class, and then there is a revision guide you can buy for at home, which is about £10. It's really, really good, really useful for them to be able to look through that at home as well. So as I said before, the exam's 60%, starts off with multiple choice questions and then goes into longer written answers. It's testing all their engineering principles and materials, and as well a quarter of it is maths. And as I said before, there's lots on costs and areas, but also covers things like stress strain, which I didn't cover until I think I went to university to learn about. So that's really good that they get to have a go and learn about those types of things already. So on this page we've got a multiple choice question, so they have to shade in which property they think it is. There's a maths question next to my head as well, so they have to cost out the different parts, and it's testing them to realise, like, can they pick out, it says 3 bolts and 6 rivets, so they need to multiply that up. It quite often asks them to do notes and sketches. So this one was to describe the process of welding, which obviously is something we teach them in class. We don't have a welding kit at Fitzwilmot, but we show them through lots of videos and discussion. And then the question at the bottom is an example, one that's near the end of the paper as well. So getting them to discuss advantages and disadvantages of CAD, computer-aided design. Who's the course for? Who do I want to see in front of me and the other engineering teachers? This course will apply to pupils that have an inquiring mind. I want the pupils that played with Lego and Connect slots when they were at home, that like to watch programs like Top Gear. How do they do that? Wants to know how things work inside. They want to know about new technologies. They might have seen my 3D printers and want to come and learn how to use them. It's good for pupils that want to learn a GCSE through practical activities, but I need to be really clear, it's not a hands-on practical course all the time. So we're about half the time on the computers, half the time designing and doing practical. It is a hard course. It's challenging, it makes them think, they've got to be independent. And whereas there's some engineering courses like the BTEC, which is much more hands-on making, this course isn't isn't that. It's a technical course. It's lots of links to physics, maths, computer science. It's really exciting, but it is hard, and they do need to be able to be resilient and have a really good work ethic as well. If they want to explore new ideas and communicate them in a variety of ways, so they're going to need to be able to present, they're going to be able to draw, and be able to write down what they find as well. We do lots of it on the computer, so they can spell check and so on, and they can present it neatly, and they can go back and they can redo, which is nice, but they do need to be able to do a decent amount of writing as well. This is a subject that's going to be really relevant to them. Everything links to things around them and things that they could take on to a career. And I think it's really good for keeping their career options open as well. So I've got some student feedback for you. If I talk you through this one, and then on the next slide, some of my Year 11s have very kindly done video for you as well, because they were saying that they found that really useful when they were students to hear from another pupil. So they really enjoy the lessons. We make them work hard, which is good. It's really useful for their career and their education. They're learning lots of new skills. Lots of them comment on the excellent support during coursework. It is a two-way thing, so we provide lots of sessions where they can come and get extra support if they need it, but they've got to be willing to come back in their own time as well to finish things off if they need to and catch up if they've been away. There's extracurricular opportunities where I can. I like to get companies in, so IPECO come into us at least once a year. They'll talk to them about their company and their career. They've got like an apprenticeship. It's called a different name. It's called a career builder now. And they like to come and see the work, and they like to come and help, which is brilliant. We've got links with Ford as well. I've taken groups there before, and the other colleges around and other companies. Oakenhurst as well over at the Weir, lots of people go on their work experience for, and it's really good to have a two-way partnership with lots of companies in the area. Many continue on with engineering afterwards. Here we do an A-level in product design, and about half of that class are engineers. Some go off and decide to do a more sort of practical based engineering BTEC at college. We get a few that get apprenticeships at IPECO, at Oakenhurst, at E2V, at Leonardo, at Ford's and so on, so that gives you an idea of some of the places they've gone on to. We've had a few that have wanted to go and do engineering in the army as well, or any other sort of practical course. So maybe they might not want to do engineering, but they want to do something construction based, and this has set them up with some good skills for that. Just above my head again is some more examples of pupils' coursework. Okay, I'm going to leave it to the students to give you some feedback.
I enjoy engineering because it's a really versatile subject. It includes elements of writing, computer work and practical, so it's a really good subject if you don't like writing all the time like me. I chose engineering because it's different from other subjects, because it's exam work and coursework, meaning that I could work on the coursework for as long as I wanted, really perfecting it. So when it came to exams, I just didn't feel as much pressure on myself because I knew that I had done really good coursework to back it up. Engineering has helped me to problem solve because we do a lot of challenges, and it's also helped me to be more creative because of all the practical work you do and designing.
I enjoy engineering because it includes drawing, designing, maths and problem solving. You get to learn every aspect of modern life, from skyscrapers to phones, and not only how they work, but how they are manufactured and designed. You have the opportunity to work in groups and by yourself to turn your ideas into reality. All the skills I have learned will benefit my future life. Since taking engineering, I have made and designed many products such as a Lasebug and LED lamp. We use online designing tools to make accurate models and also create circuits. To make our products, we have high-tech machinery such as the laser cutter and the 3D printer. Therefore, this allows us to make a range of products in different ways and different materials. In Year 11, I have the chance to show off all the skills and information you have learnt throughout the years by making a product based on the exam specification. I have thoroughly enjoyed engineering and I recommend it for you.
Okay, hopefully you found that useful to hear from a couple of the Year 11s. Engineering is still a very male-dominated sort of area, but as you can see, we have lots of girls take the subject as well, which is brilliant. Still more boys at the moment, but they didn't want to do a video for me, I'm afraid, but at least you saw some of their comments as well. So in summary, it's a technical GCSE. So there's lots of thinking, lots of maths, lots of physics, lots of computer science, lots of problem solving, all coming together. 40% portfolio, which is great because that means when you walk into the exam, you've already banked a nice proportion of your grade already. We do practical work, we do computer aided design, we do written work, we do drawing. It is a big range, and it's quite nice because each lesson you come in, you might be doing something different. So it won't be just be sitting at a desk, we'll be moving about and doing different activities. Lots of new technology to learn about, new machinery that you get a chance to have a go at. As I said before, we've got nice links with industry, and I think engineering just has those real transferable skills. They're going to be problem solvers, they're going to be independent, they're going to learn how to write different types of reports, they're going to look at costing, which is brilliant for any career when they go forward. If you have any questions at all, my email's at the bottom, cbollens@fitzwymark.com. Please do get in touch, and I look forward to hopefully having lots of great engineers next year.